So sequencing of DNA is the final method that we can confirm any DNA or the plasmids. So this is a gold standard in terms of confirming any plasmid or DNA fragment. So it's just sequencing the every single nucleotide in a DNA fragment or a base. So this actually done by a Sanger sequencing process, which is developed by the Frederick Sanger at the University of Cambridge in 1977. It involves the in vitro DNA synthesis and based on the DNA replication process. So what is the Sanger DNA sequencing? So we know that in the nucleotide, we have a ribose sugar, deoxyribose sugar, and a phosphate and a nitrogenous base. So in normal process of a DNA replication or extension, the polymerase need a 3' hydroxyl group at the 3' chain to form a phosphodiester bond for the incoming nucleotide. So Sanger sequencing is developed in a process that this deoxy nucleotide is actually replaced by dideoxynucleotide, DDNTP. So DDNTP. So this is actually remove the oxygen group, the hydroxyl group from the 3' end with just a hydrogen group. So what is happening then when there is a incoming nucleotide is coming up, there is no 3' hydroxyl group for the DNA polymerase to join the next nucleotide or form the phosphodiester bond with the next nucleotide. As a result, the synthesis of the DNA fragment is stopped. So this is the process which actually used in Sanger DNA sequencing. This is the mechanism. So for this sequencing mechanism to proceed and identify the sequencing, so each tube has a single dideoxy nucleotide and the other normal nucleotide. So for in this example, so this tube has only the dideoxyactine triphosphate, but all the other nucleotide like the thymine, guanine, and cytosines are the normal one, that is the deoxy one. So they can actually join together, but whenever there is a thymine, so then it needs to be added a adenine. But because this is a dideoxy adenine, so after this one, the reaction has been terminated. So in this way, so when we have got the next thymine group, so another adenine need to be added. So again, this is a dideoxyadenine, and the reaction has been terminated. Same process has been happening for the dideoxycytosine, dideoxythymine, and dideoxy guanine. So as a result, that we have got a fragments which is actually separated by a one base pair. And all these dideoxynucleotide has been radiolabeled. So they has been actually detected by the chromatogram, which is actually using these days. After all the reaction has been completed, these fragments has been pushed through a capillary electrophoresis and detected by the radiation and get detected into the computer as a chromatogram. And by this way, we can know that which base is actually adding, or what is the sequence of that DNA. So I have added a few videos for the Sanger sequencing, and I'd like to request you to go all of them, just look, just see all of them, watch all of them. So that would be uh, really helpful. And after that, if you still have any questions, there is always a discussion class. We can discuss all these later. Thank you.